Okay, so now you're going to go ahead and join this piece in there. We're going to pick, and I just picked this top center hole here. Again, it's kind of difficult to get that center point, but if you're just patient, zoom in there on it, you can do it. Click that center point, rotate it around, and go to the same center point right here. And it's weird how it moves that, but if you go OK, it snaps that into place there perfectly. All right, looking good there. So now what we're going to do is we're going to put in this other end beam. So I'm going to open back up here, and that is underneath of our channels folder. So we're going to go to channels, and we're going to pull in another 9-inch channel. When we pull in this 9-inch channel, we're going to put it in basically a mirror image of what this one is over here. So we're going to rotate it down in this direction 90 degrees, and then rotate it here 180 degrees. And then slide this into place. Now, it's a little bit lower than what it needs to be. Oh, I got mine a little bit crooked there too. There we go. Now I think mine's straight. So right there, and I'm going to go OK. All right, so now on this one, we're going to do something a little bit differently. Sometimes on your robot, having a bracket here on the inside of your robot is a pain. You sometimes have a game piece that needs to go into this position all the way back, and with that bracket there, you can't. You might have a motor or some other part of your robot that has to go into this position, so you can't have a bracket here. One option is to put these plates on the top and the bottom. However, these plates, they're just a little thin piece of sheet metal. They honestly are not quite as strong or not as durable, not as sturdy as these corner brackets. These corner brackets are a pretty beefy piece of metal, and they really hold things really well. So just using these plates is not always a good option. So an option you have is this. We're going to go back to our brackets. We're going to pull in our same 90-degree angle bracket. We're going to pull it in here. And now what I'm going to do with that bracket, I'm going to put it on the inside right here. So where the flat portion of it points out here, and the other flat side fastens to here. So the way that's going to look is like this. Let's rotate this one down in this position, 90 degrees. And around, whoops, and around this way, 90 degrees. To right there, and go OK. Well, actually, I'm going to slide it a little bit closer into place there and go OK. All right, so now what I'm going to do is this hole that's on the back side here that I can get to, I'm going to put the center of that hole to the center of this hole and get that into place. So I'm going to go to joint, rotate this around to the back side, get the center of that hole, and I'm going to join it to this hole right here. That puts that there in place nicely. This piece is flush out here. I'm going to go OK. So now all I'm going to do is I'm going to join this bracket, again this hole right here, to the back side of that hole. So again, I'm going to go joint, put that hole right there, the center of it, centered up with the back side of this hole. It does just move that one piece, but if I go OK, it slides that other one over there into place. So that's nice. That's a very solid joint there. It's looking great. Now here, however, you're going to notice one other little tidbit that this does. When I rotate this around to the top side, notice how it offsets this plate in, or this beam in, this channel. It's in about 0.1 inches, which is the thickness of the metal of the backside of this channel. What that does for you is it makes it to where these top plates won't line up. So a top plate like what we did over here won't line up and won't work. The little bracket we did on, whoa, I spun that around the wrong way. Little bracket that we did here on the end of this, the holes of it won't line up. So what it does is if you do this, and it's a fine decision to make on your robot design, it makes to where the only bracket that will really work is this corner bracket. So since we need to connect both corners together with two brackets, the only option it really leaves you is putting another corner bracket up here on this top surface. So you're going to end up putting a bracket here on this top surface here. Same thing on this other end, one here and one here. Again, it's a design choice as you're designing your robots next year, or once you're designing your kind of free robot you're doing this year, on what you want to do. If the benefit of having those brackets inside of your frame outweigh the bad portion of it not lining up here on the top, it's a total fine decision to make. The sample robot that I have here in the room is actually put together that way. All right, I'm going to pause the video, get these 4 brackets put in, or the other 3 brackets put in, and show you what those look like. All right, so there, I now have those 4 brackets in place. If you notice here, one on the top, one on the bottom there, and one on the top and one on the bottom here, all joined into place, all put into place with the joints. All right, so now next, what we're going to do is we have to put a top plate on this robot up here. That top plate, typically when you build your robots, it's a clear piece of Lexan. You're going to put those there on the top of your robot. So to do that, it's a little bit strange. In Inventor, you would have just came in here, put a sketch on this top surface, and done that. But now notice if I go to do that, it highlights every one of those holes that are out there. If I do this, it recognizes every one of the holes when I go to extrude it. We did this on the first one we did the other day. And you have to select each one of those holes individually or deselect each one of those holes individually. It is a real pain. There's a lot of holes in this bracket. Back in the day with Inventor, you could have selected those holes, but you would have had to done something special. It's called project them, and you would have projected them, and then you could have recognized those holes. Here, Fusion automatically does it, which is a little bit of a pain. So the workaround that I did is this. Instead of just sketching on that surface, we're going to do something similar that we did the other day, which is create an offset plane. It's right here. If you click down on this, you can see all the different planes you can do. We're just going to do the, whoops, I clicked wrong there. We're just going to do the offset plane, which I can do just by clicking here at the top. It's that top choice. On the offset plane, you're going to do it anywhere on the top surface of any of these pieces out here. It doesn't matter which one. So I'm going to scroll in here, make sure I find that top surface, click, and do my offset plane. Now, the crazy thing it does here is the offset plane that you do, you don't have to do it actually offset. You can leave this number at 0 and just go OK. It creates another plane that is called an offset plane, but it's right there on that same surface. Now what we're going to do is we're going to create our new sketch. Make sure and be careful when you select this. I'm going to zoom in here a little bit. Just don't come out here and click because you might get that top surface. But make sure and get the actual plane right here, that yellow plane. Click on it. And now I've created that plane there on that surface. This makes things very easy. Now what I'm going to do is I'm going to draw my top plate. When I'm drawing my top plate, to me it's a little bit harder. If I click here, I probably can get it connected to the surface or that corner, and it'll be a nice black line. But I've found it's easier. I think I just draw it on the outside, and I draw it a little bit larger, and it's really easy to use collinear at the end. So I'm going to start it here and draw around. Now, if you have those top plates on there, as I do, all of you should have this one, draw around it like so. If you have the other top plate over here, draw around it also. I do not have another top plate here, so I'm just going to go out past the object out to here. Let me see 1 second here. Why that line did not draw, I'm not sure. Interesting. I'm going to finish mine out and come back and draw that one line. Down to there, over to here, make it the same length as that one. And up. Well, I don't know what I'm doing on my lines. I'm going to have to draw in a couple extra ones here. I don't know why. It's all good though. All right, so there's that nice surface there. From there, you're going to go through there just with your collinear. You've all done this a lot of times. And make this side collinear to that piece. Make this one collinear to there. And this one collinear to there. Do that all the way around. Down here on the bottom edge, you're going to have to make a choice whether to make it collinear to this piece or to this one. It really doesn't matter either way. I'm going to make my collinear there. All right, so with the magic of me pausing the video, mine are all black all the way around, the outside edge of this, collinear all the way around. So my sketch is all black. I'm good to go. I'm going to finish my sketch. I'm going to go ahead and extrude this. It should automatically recognize it there just fine. If it doesn't, you should be able to click out there in the middle. And we're going to extrude that at 0.1 inches. So 0.1 and OK. That's great. We've got a nice gray top to this. However, I want this to be a clear piece of plastic that I can see through. We're going to do something we haven't done yet. If you've got yours set to where you're on the component color cycle toggle, you want to turn that off. Remember, that's up here under Inspect and down here. You want to turn it off, otherwise you can't see what we're going to do next. So what you're going to do, you're going to click on that top surface, you're going to right click, you're going to select it, you're going to right click, and you're going to go down to Appearance. Under Appearance, we're going to come in here. I have a few things already open on mine. We're going to come down here where it says the Library. Under the Library, we're going to scroll down to where it says Plastic and open up the plastic. Normally it's closed here. We're going to open up the plastic folder. In the plastic folder, I'm going to scroll down, and I actually want to open up the transparent plastic folder. So transparent. And then we have all these options. I have clear acrylic, red acrylic, amber, bronze, and clear polycarbonate. We're going to go to the polycarbonate. If you don't know anything about plastic, polycarbonate is a stronger plastic. It doesn't crack. It's not brittle. So we're going to go clear polycarbonate and click and hold on it and pull it up here beside this one. So now I have this in my design, and I can come in here another time and pull this over the clear polycarbonate. We're going to use it probably for other things. And now I'm going to click and hold and pull this over to my top sheet and just let go of it right there. And it turned this top piece into a clear piece of plastic. That's what we were looking for. All right, that looks great. Now next, what we're going to do is we're going to put in the control of our robot. So what that is, we're going to go back to our main folder. Main folder, we're going to go down to control, and we're going to look here at the control. Some of these parts are parts you no longer need. Back in the day, the control of the robot, the brain, was a cell phone. And this is a cell phone holder that we created in Inventor, and then we made it out of clear plastic on our not out of clear plastic, sorry, out of plastic on our 3D printer, and that's what we used for our robots in the past. Now, however, they have revamped the expansion hub, the Rev expansion hub, and now it has the capability of taking that signal for your robot, and you no longer need the cell phone. So all we really need is this Rev expansion hub for the control of our robot. We're going to pull it over like so. Now what I want to do is I want to place it, this is, I'm considering the back of the robot here, that first 9-inch plate that we put in. I want this to line up against that back part of the robot. So the first thing I'm going to do is I'm going to rotate this thing down 90 degrees in this direction. And then I'm going to spin it around, spin it around, if I grab the circle, in 90 degrees this direction. And pull it up here on the top surface and right there. So I had the word Rev right back there lined up with that back side. I'm going to go OK. So there it is in place. Now we're going to constrain it or join it into place. I'm going to move it up just a hair more. To do that, I'm going to go to my joint. This is a little bit tough, but not too bad. I want to highlight the bottom surface and get that midpoint right there. So bottom surface highlighted, the midpoint of the object right there. Click. And I'm going to put it on the midpoint of this polycarbonate sheet. Now, if you had 2 notches on your polycarbonate sheet, I really don't care. It just centered up into this space or centered up in the other space that's left. It's really not that vital. So again, I'm going to highlight this top surface, and then get that midpoint, click there, and it should move over there. If yours goes up in a weird 90-degree angle where it's sticking straight up, you didn't get the top surface or the bottom surface quite selected correctly. And just try it again. So OK, and that piece is in place and looking great. Next, what we're going to do, one thing you do, however, still need is the battery pack. So we're going to put our battery pack in there. We're going to drag our battery over there. This part of the battery with the wires on the bottom is kind of hard to see there. That is the bottom side of the battery, so we're going to rotate this around 90 degrees to there. And that's fine. Now I'm just going to pull it up a little bit to the top surface. I don't want it right on top of the expansion hub, so I'm going to drag it over into an open spot. Make sure I'm at least above the surface a little bit. And right there looks good. I'm going to go OK. All right. So now there's my battery sitting in there. Nothing's holding my battery into place yet. Now here's something that, a little bit of robot design. Every competition I've ever been to, I've seen multiple robots flipped over and on their top. One thing that we really stress to you guys as you're designing your robots is your batteries are fastened down solid. Because if your robot flips upside down and your battery comes loose and your battery's sitting on one part of the field and your robot's on the other, your robot's not going to work real well with no battery on it. So what we do to get this into place is we put some pegs in here to hold this in place. Those pegs are called standoffs, and those are going to go back to the main folder. On your main folder, you're going to scroll down. I'm trying to think where those are. Those are underneath of shafts, I believe. Shafts. Oh, nope, they're not shafts. Those are... maybe they're spacers. I think they're spacers. Yes, there they are. Spacers. You're going to pull in 4 of these. So I'm going to pull in 1. I'm going to rotate this around so it's pointing straight up. Oops, wrong one. Pointing straight up. And then I'm just going to put it in place over here on that top surface somewhere. Yeah, right there is fine. Okay. Go ahead and put 4 of those into place on your top surface. All right, so there I got those 4 pegs sitting on the top surface. Next video, I'm going to show you how to get those pegs put into position and how to get your battery locked into those pegs. All right, good luck.